Welcome to the second video in our lesson on graphing relations. So in this first example, we have to complete the input-output table using the relation 3n plus 2, and then we have to draw the graph. Now here is my expression. Now the first input value is 1, meaning we replace our n value with 1. So 3 times 1 plus 2 is going to be 3 plus 2, which is 5. Now we have filled out input-output tables in previous videos and evaluating expressions as well. So if you need extra explanation, you can go back through some previous videos. So now let's replace n with 2. 3 times 2 is 6, and adding 2 to that gives us 8. Now n is 3. 3 times 3 is 9, and adding 2 gives us 11. And lastly, n is 4. 3 times 4 is 12, and then plus 2 gives us 14. So now we're going to take these input-output values and put them on a graph. So here I have my graph, and I already have the input values labeled on the horizontal axis and the output values on the vertical axis. Now whenever you do a graph, it's important to look at the scale. On the bottom, the input values just increase by 1. And the same for the output values. Even though every number is not written in, 1, 2, 3, 4, all the way up to 14, every block has a value of 1. If I had to write all the numbers there, it would be a little bit jumbled. So that's why every second number is left out. So now let's go ahead and take these values and put them on the graph. So our first set of points is an input value of 1 with an output value of 5. So if we start at 0 and go over to an input value of 1 and then up to an output value of 5, we get our first point right here. Next we have 2 and 8. So we can go over to an input of 2 and up to 8, giving us this point here. Then we have 3 and 11. So over to 3 and up to 11 gives us this point. And lastly, 4 and 14. So over to 4, up to 14. Now you'll notice that all of these points are in a straight line again. So we have what's called a linear relation. I also notice the fact that we have a linear relation from the input-output tables and how they increase by the same number each time. All the input values increase by 1, and all the output values increase by 3. Now for the next example, it says, for Halloween, the Dumpy family buys a package of 250 lollipops to pass out to trick-or-treaters. Now they give 2 lollipops to each person. Write a relation to show how many lollipops remain for T trick-or-treaters. And because we don't know how many trick-or-treaters they will get, we can use the variable t in our relation. So they start off with 250. Now since they're giving away lollipops, we're going to subtract 2 lollipops for each trick-or-treater. So our relation would look like this. 250 minus 2 times t. Now we're going to use this relation to help us complete the table. So writing down my expression, I'll first replace t with 10. So 250 minus 2 times 10. So we have to do the multiplication first. 2 times 10 is 20. 250 minus 20 is 230. So now we'll repeat that process, this time with t being 20. 2 times 20 is 40. So we have 250 minus 40, which is 210. Now t is 30. 2 times 30 is 60. 250 minus 60 is 190. 2 times 40 is 80, giving us 170 lollipops left. And if there were 50 trick-or-treaters, 250 minus 100 gives us 150 lollipops remaining. Now for part C, we have to graph the data. So here is the table of values that we filled out on the previous slide. Now let's talk about the setup of the graph for a moment. I have the number of trick-or-treaters on the bottom, and I have the number of lollipops on the side. Now whatever's in the top row of a table of values always corresponds with the horizontal axes, and the bottom row always corresponds with the vertical axes. So that's how you know where to put your data. Now let's talk about the scale. The number of trick-or-treaters increased by 10, so every block on the horizontal axis is worth 10. Now what about the vertical axes? Every block there is worth 10 as well. So it goes 0, 10, 20, then 30, then 40. And once again, not every block is marked because it would be too cluttered. Now one thing this graph is missing is a title. So let's add that. Let's say this graph represents the number of lollipops remaining versus how many trick-or-treaters there are. So now let's go ahead and plot our first point. For 10 trick-or-treaters, we have 230 lollipops remaining. So I start at 0 down in the corner. I go over to the right to 10 trick-or-treaters and then go all the way up to 230, and that will give me this point right here. Now if I went over to 20 trick-or-treaters and then up to 210, I would get this point. 30 and 190 would be here. 40 and 170 right here. And lastly, 50 and 150 is right here. So all these points are in a straight line, so this is a linear relation. Even though the points go down, whereas the other graphs we had all the points were leaning upwards to the right, these points are going down. That's because you're giving away lollipops and the number you have decreases each time, but it's still a linear relation. Now for part D, it says use the graph to determine how many lollipops are left if there are 60 trick-or-treaters. So if I look for 60 on the horizontal axis, I look up for a point and notice that there's none there. So let's go ahead and continue the pattern on the graph so we have a point when t is 60. So if I look at the top 2 points, I notice that I go down 2 blocks and over 1. And that's the same pattern for each set of points. So I can go down 2 blocks and over 1 and mark a point right here for 60. So now if I look straight over on the vertical axis for the number of lollipops, I see that that is 130. So now for 0 trick-or-treaters, I know already that they should have 250 lollipops because that means they didn't give any out. But let's look and confirm that on our graph. So here is 0 trick-or-treaters. So I notice that there's no point on the vertical axis for this, but if we continue the pattern of going up and over 1, then we have our point right here, and that does correspond to 250. Now lastly, we have 25 trick-or-treaters. So that would be right in between 20 and 30. So if I go straight up and then straight over, that means that they would have 200 lollipops left. So now you can continue your work on graphing by looking at the next video in this lesson.